this section, let's learn about service discovery with Kubernetes. So service discovery is a mechanism for applications and microservices to locate each other on a network. So you actually use service discovery, but I didn't tell you, I just showed you the magic that happened with Kubernetes. But now let me actually tell you what is happening. So service discovery happens through services. And remember, I've showed you this diagram where we have a client, and if the client wants to communicate with our application, we shouldn't really be using the individual pod IP because pods are ephemeral. They come and go. We shouldn't rely on them. Instead, we should rely on services. And this is because a service has a stable IP address and also it has a DNS. So what is DNS? Let me quickly show you the definition of DNS before we proceed. In here, in this Cloudflare blog, they explain what DNS is, and I'm going to leave a link on the description of this video so you can follow along. But basically, DNS stands for Domain Name System, for short DNS, and it's the phone book of the internet. So we humans, right, we access information through domain names like nytimes.com or espn.com or amigoscode.com, so on and so forth, right? And the web browsers interact through internet protocol or IP addresses. Now, DNS in here translates domain names to IP addresses so web browsers can load internet resources. And what I want to show you is how service registration works. So this is not the actual full-blown example, but this is visually so that you understand exactly what is happening. So in here, when we create a service, we basically register each service to our service registry. And most clusters actually, you'll see core DNS. So this is what is doing all the magic. But basically, you can see that anytime that we create a service, this registers the service name as well as its IP on the service registry, right? So remember, we talked about controllers and watch loops. So basically, anytime that there is a change on our services, we get an entry in our service registry. Then on the other side, this is where, for example, the consumer, right? So a pod or an application can consume whatever data or API that the service exposes by just using the name. So we should never really be using IP addresses. So let me actually show you what core DNS is. So in here, I'm inside of this webpage, coredns.io, and DNS and service discovery. So basically you can read information about it, but basically core DNS is a DNS server which is written in Go, and it's very popular, fast and flexible, simplicity, and also it's part of the Cloud Native Computing Foundation. And you can see some of the users. In first place, Kubernetes right here. So this is really cool. Now, so core DNS is actually another topic on its own, but I'm going to leave this link so you can follow along and read more about it. Right, the last piece of the puzzle that I want to talk to you when it comes to service discovery is kubeproxy. So early in this course, when we learn about the Kubernetes architecture, you saw that each node has these three components: the kubelet, container runtime, and kubeproxy. So let's focus on kubeproxy because this fits in with this section. So the kubeproxy is a network proxy that runs on each node, implementing part of the service. So we've been learning about services, you've learned about cluster IP, load balancer, node port, so on and so forth. So basically, kubeproxy is part of the Kubernetes service. It maintains rules to allow communication to pods from inside and outside of the cluster. Also, early in this course, you've learned about watch loops and controllers. So the kubeproxy also implements a controller that watches for the API server for new services and endpoints. So you've learned about services and endpoints and how they tie together. Now, when there is a new service and endpoint, the kubeproxy creates a local IPVS rule or rules that tells the node to intercept the traffic destined to the cluster IP, to the service cluster IP. Now, this is important, right? So the name Kube Proxy. So here it creates a local IPVS rule or rules that tell the node to intercept the traffic destined to the service cluster IP. Now, you might be wondering, what is IPVS? So IPVS stands for IP Virtual Server, and this is built on top of the NetFilter and implements a transport layer load balancing as part of the Linux kernel. And basically what it gives us is the ability of load balancing to real servers, as you've seen when we use services where we have a bunch of pods which are behind the service, whether it's a node port or load balancer or cluster IP. And when the traffic is received, then the service load balances between healthy pods. And this is possible because of IPVS. Now, I'm going to leave a link on this where you can go and learn more about this, because this is more on the network side of things. But under the description of this video, you can find a link to a page that teaches you more about IPVS. Then what it does, it redirects traffic to pods that match the service label selector. And to be honest, this is the main role of Kube Proxy.